Hi everybody, good afternoon. My name is Ms. Jackie. Thank you for joining us here at Chula Vista Public Libraries. My first STEAM presentation of 2021. In a little bit you're going to see my colleague Susan as we share with you this project of artificial gravity. Artificial gravity, as best as I can kind of explain it to you, is think of an astronaut in space who spends a lot of time on that spaceship. Artificial gravity is kind of created to help ease the loss of bone and density mass in their bodies. But let's first talk about what regular gravity is. So gravity is when you have a gravitational pull between two masses kind of attracting each other. So you have my mass, which is significant in itself, but when it compared to the Earth's mass is huge. So it's, while it's pulling me down, okay, my mass is pulling me down, but then the Earth is pushing me back up, which allows me to stand straight, and I'm not floating off into oblivion. So that's why, like, if you're in a pool, there's not much gravitational pull in that way, so you're floating inside the water. That's kind of like what happens in space. There's no huge gravitational mass pulling everybody up together, attracting each other, so they have to kind of make their artificial gravity. Okay, so in space, kind of what you see in movies, sometimes you'll see a spaceship spinning on, just spinning around. That's kind of, in a way, we could do that. In order for the spaceship to have a gravitational pull from the Earth, it would have to be a spaceship as big or bigger than the Earth, so that's kind of impossible. So in movies and such, you'll see the spaceship floating around and using centripetal force. So the artificial gravity we're going to be talking about is going to be showing you centripetal force, kind of how things stay in place. For instance, when you're on a roller coaster, how do you stay in place as it's going fast? When you're in a car and it kind of turns a little bit too fast, the centripetal force of the car's motion, you're going to feel that door pushing up against you as it's forcing itself on you, and you're forcing itself on the door. Centripetal force. So we're going to explain that to you in kind of a fun way, and maybe you can explore it on your own and let us know how you do. Okay, so this experiment with the spinning bucket, it's actually going to show the relation between motion and gravity. So what you're going to need is a bucket with some water and someone with a strong arm to spin it. We have here Miss Susan, who's protected herself with an umbrella. And in theory, when the bucket turns upside down, the water should come spilling out as gravity pulls it downwards, right? However, spinning it fast enough, the water tends to keep going in a straight line, counteracting the pull of gravity and thus wedging it to the end of the bucket, preventing the natural pull of gravity from spilling the water. This is why the effect, called centrifugal force, is often referred to as artificial gravity. Okay, so this next one is called a hole in the cup. So obviously you're going to need a paper cup and, again, some water. So poke a hole in the cup and then cover it with your finger. Then fill the cup with water. Take your finger from the hole, as you see me doing here, and notice how the water spills out. Though gravity pulls down both objects, only the water moves freely because, why? I'm holding the cup. Therefore, gravity forces the water out. Now, I'm going to fill the cup again and drop it to the ground. Now that they're both free to move, both the water and the cup, they drop at the same speed, so the water isn't forced out of the hole. Fancy schmancy, huh? Okay, so what this challenge really is about is for you to experiment with gravity, air resistance, and terminal velocity by making your own miniature parachute. So you're going to need a paper cup, some string, and a plastic grocery bag. So what you do is you punch 4 equidistant holes around the rim of your paper cup, tie a piece of string a length to each of those holes, and then attach the other ends of those strings to the corners of a parachute which you have cut from a plastic bag. You can stand on a ladder, maybe a step stool, or maybe even just a step, and you drop the cup. Okay, so you may need to experiment with the size and shape of the parachute and the lengths of the strings before you can, try to challenge and reliably send the cup down without spilling whatever you have in it. So if you're gonna, test the parachute before you put anything in it, such as pennies, rocks, or what have you, test it out and see if you can actually land it safely. And then put the items in the cup and see how reliable your parachute is. I'd hope to hear back from you soon, okay? Thanks. Now, if you like this experiment, if you like this STEAM event, I encourage you to like us and follow us on Facebook, Twitter, Instagram, and please continue to support the library. We love you, we miss you, but we want you to stay safe out there, and we will see you soon. Take care, everybody.